Okay. Okay, are there any questions before I start with a couple of slides and lectures? Go ahead.
How do you simulate middle click with Mac?
With the Mac. So what I said last time was to go and download Magic Prefs.
Yes.
Okay. So in Magic Prefs, you can establish. There's a couple things you have to do. You have to basically. The way I set mine up is I let it remember that a double tap on your Mac
Oh.
will be a middle click button. So that's why I recommended people getting a 3-button mouse just for this purpose. But if you don't have a 3-button mouse, you want to use Magic Prefs to give you to simulate a 2-button middle mouse button.
So I can set it up myself.
Yes, Magic Prefs, you can set that up yourself. But so hopefully I won't be using too many things. The only thing that I actually use that for is the cutting and pasting, and also checking out the options for Xterm. Right? And we'll go over that a little bit more. I was actually able to find some of my old notes from almost 10 years ago. So I'll go over some of the things that you might have missed if you came in late yesterday. So I'll just reiterate some of these things. So Unix history, 30 years. That's probably more like 40 years now. And a couple of the, as I mentioned, very last time, there's several flavors. There's what's known as the BSD for Berkeley Standard Distribution and System 5 flavor. So way back when AT&T developed Unix, and because AT&T was a monopoly, they really weren't supposed to get involved with computers. And being that they can't do anything with it, they actually licensed or gave the source code over to Berkeley, University of California, Berkeley. So that's where the BSD comes from. So it's known as the Berkeley Standard Distribution. And System 5 is one that AT&T kept. And now, after those two major versions, came Linux by Linus Torvalds, who basically said, I want to run Unix on my PC because Unix is fairly compact. It was meant for computers back in the 70s, so that any newer computers should run much quicker with it. There's not as much bloat as it used to be. The other flavor that we see nowadays is the on the Mac, and that's more of a free BSD version. It's not quite the same as Linux. So there are some variants. There are some commands that exist and don't exist in different locations. And as I mentioned, it was originally developed by programmers for programmers, so that it's not really wasn't usability was not one of its strong points, and that's unfortunately something that that came about in terms of legacy for Unix. It's kind of one of these macho things, which like you can say, oh, if I know Unix, then I'm better than the other people that I'm working with, which in some respects actually is somewhat true. So. Way too many commands to cover. What I hope to do is sort of show you some of the commands that I use, not so much on a daily basis, but I've found to actually help optimize a certain workflow. Right? And a lot of these things will seem a little hacky because of the fact that you have to know certain tricks of the trade in order to get things to work. But hopefully in framing it in a problem that you may face in imaging, and not just in imaging, but in manipulation of data, you'll remember them. Okay. It's open source, which is one of the reasons why it's proliferated so much. Is that you know, everybody can look at the code, everybody can analyze it, add to it, and which is something that you can't do with commercial software such as Windows. if there's a problem with Windows, only Microsoft knows it, or the hackers who are trying to get zero-day vulnerabilities that find them. With Linux and Unix, you can look at the source code. If you want to, you can go in there and modify it yourself. It takes a bit of technical knowledge, but it is possible. So let's see, where's my menu? Command lines. Why do we want to do command lines? Well, a lot of the things that you probably do in imaging or probably initially is probably use a graphical user interface to interact with with some kind of program. But one of the things that you'll find out very quickly is that it tends to get in the way when you have to deal with images that are in the order of hundreds, thousands, and not just images, but also files that are associated with those images. You have to somehow extract information from it and modify that information, maybe do some calculations, and then do some processing. So many of you will probably find yourself doing a lot of sensitivity studies where you change different parameters in your studies and run them in like a cluster-like computing infrastructure. So we'll just go over some commands and how you control some of those jobs. And let's see, and we'll do a little bit of shell scripting. I don't know how far we'll get into that, but I'll at least give you very, very simple shell scripting examples that you can expand on later in the road. So this is old stuff. That's just really old stuff. So don't worry about that. So the original desktop, Unix desktop, is the $. As I mentioned last time, we have what's known as the bash, not the bash, the Bourne shell. All right, and that's typically indicated by the $sign as your prompt. Some of you may have different prompts on in your Unix system, but in general, the default prompt, if your system administrator didn't put any sort of ornamentation, such as your username or your current working directory, typically you'll have just a $. Prompt for Bourne shell. Also, and the other shell is the C shell, which is typically indicated by a % prompt. Right, so some of you may see that, but in the past few years, with the prevalence of Linux, you have the Bourne again shell, which is what Bash refers to. Okay, Bash is simply an expansion of the Bourne shell and modernized to allow some more scripting capabilities. So that's what you'll be working with. Let's see, what do I have here? Again, C shell, Bourne shell, and I don't have it here. This is Bash, but these slides are like 10 years old, so you'll have to excuse me. Oh, I did say that. And then there's the TCSH, which allows you. The only thing I've found out about that is it allows you to do up and down arrow keys. So Bourne again shell, Bash. So let's see. If you want to find out what your shell is, you can do echo $capital shell, right? And that kind of tells you what your shell will be. And before I go to, let me see what the next slide is. So a shell is just basically, think of them as your prompt or your terminal that you're dealing with. And each of these shells have its own environment. And as I mentioned in yesterday, you have that .cshrc and that bashrc. You don't have to do this. This is for an old class that I used to teach. I used to let people know about this particular command, but it's something that I haven't used in a long time, probably because of the fact that I'm very comfortable with Unix. But if you're not, you can actually use the script command. And what it'll do is it'll actually save your session, all right, and into a file so that you can actually see everything that you typed, okay, character by character. It's kind of annoying because it actually saves everything, such as your backspaces and all the mistakes that you made. But for some people, it might be useful to just be able to look back on a history of what you've done and what some of the results were of that process. As I mentioned in the last class, the end of a file is a control D, right? So I mentioned that Unix basically treats everything as a file. Your keyboard is a file. Your screen is a file. Any network connections are treated as files. So in order for the keyboard to indicate what the last end of file is, you have to do a control D, and that's one of the special commands that you have there. Okay. So before we actually go into this, I'll actually show you how I start up an Xterm from both a PC and a Mac. So on a Mac, because this is already a Unix system, you just have to start up Xquartz. I think Xquartz, right? And when you start that, it should start up with an Xterm for you. Xquartz is basically for a Mac, the X Windows environment. So what I mentioned in last class is that X Windows is essentially a way for a local machine to actually connect to another machine that understands that protocol. By being able to do that, you can actually run things from your local machine that is running on another machine, a server, for instance. So in reality, what you can actually do if you have access to a machine over in Europe, for instance, if you have a login there, you can actually control that machine by running programs on that machine and still have the control back to your laptop. All right. So instead of running things locally on your laptop, you can control a much more powerful machine out on the internet. So this is just how Xterm looks like how I started it up. On a PC, however, if you had followed the instructions that I gave, I'm actually going to connect to the one that I have on my desktop. If I can figure out how to do that. Come on. And I'm going to do a remote desktop connection to it. And I will show you what a properly installed Xcygwin environment looks like.
What's the difference between using the Xterm on the Mac and just using the terminal that's already on the Mac?
You can't do X Windows protocol. So if you try to run terminal and then you SSH into Armstrong, for instance, and you try to start Envy, it'll say, "I don't know how to talk. I don't know how to talk to that machine." So that's why it's a critical piece to do that. You can do a lot of the Unix commands, but anything that involves graphical interaction won't work. Okay, and that's why some of you may have just installed Cygwin. That's basically the same thing as just having a terminal.
Okay.
So and that's why I said Xcygwin will give you the capability to control that. Yep. No, that's a very good question because it's not obvious. It's like, why do we need Xterm? And that's one of the reasons. So this is on my desktop, and connect to it. And what you'll see, and prove that this is an actual PC, is that when you go here, there is a file or so here you go. We have Cygwin and we have Xcygwin. So actually, just for demonstration, let's go ahead and start up just a regular Cygwin terminal here. All right, and I can now SSH into Maybe. I didn't, okay. I can SSH into Armstrong. What's that? No, I'm gonna get into that in a few. What I'm doing is I'm showing the difference between Cygwin, regular Cygwin, and Xcygwin. So if I say SSH, okay, you'll typically see this if you logged in for the first time. Oh gosh, that's horrible. I can't. You guys probably can't see that, but. And that's one of the reasons I also use Xterm, because I can actually adjust the size of it. I think it might be able to adjust the size here, but I don't know how to. If I say if I tried to, oh wait a minute, it's Homestar. I didn't get the login. All right. Say yes, and then my password. Okay. And if I tried to start Envy, for instance. See, it'll say no display. No, you can't see it, but it says you can watch this after the fact. No display available, okay? Because it doesn't understand anything about X Windows. So let's exit out of here, and I'll show you how Xcygwin works. Right, I'll exit out of here. So a properly configured Cygwin environment on a PC, you should be able to look at this, and that says Cygwin-X. If you click on that, there's what's known as a server. Okay, and the server basically starts up a process that allows it to talk to the remote machine and negotiate how the programs running on that machine will interact with your keyboard and mouse on your laptop. So it's as if you had taken a wire and connected it directly to that machine so that you can use your keyboard and your mouse to control a program running on a different machine. All right. And what we should have now is, while we wait for this to start up, a window that will essentially be an Xterm window. All right.
You launched Xserver, yes?
Yes, I did launch Xserver. And it should take a little bit of time for that to set up. I think I did do that. Did I launch it? To find out, you can actually click here, and then okay, and that's this is indicating that if you click on the tray, this is indicating that Cygwin is actually started up, and it's probably just going through the mechanics of setting up an X window. If you are impatient, you can actually right-click on this, and it will tell you which, it'll give you an option to see which applications you can start. So you can actually start an Xterm here. Yes?
I went to the Cygwin site and I downloaded the Cygwin, like you just showed a minute ago.
Yep.
But where do you get the X version?
What you have to do in that situation is when it goes through and asks you what packages you want to do, you have to click on an area there where it says install everything.
Oh,
Okay.
Full install.
You have to do a full install. Okay. Now, if you don't do a full install, a lot of things get left out because some people just don't care about it. But in my experience, if I try to handpick those things, there's more of a chance of me forgetting which one to do. So I just do a full install and just let it run overnight. So, okay. Yep. So if we didn't have Xterm started, let's actually see if we can start it up manually, which I just did. All right. So that shows you how to do that. And then you can adjust the fonts using the control button and the right click. Okay, so control and right click will give you the those options. Control middle click will give you more options. The useful things here are reverse wraparound. Okay, so sometimes when you actually type a command and it goes to the end of the line, if you don't have that set, it will just keep typing on the end of the line instead of being able to see it wrap around to the next line. So a very minor issue, but very annoying if it's not set properly. Okay, and then left click, control left click, you get a whole bunch of other options that I don't use as often. But let's go ahead and make this bigger. So I'll go do a control right click and make it huge so you can see it a little better. All right. So just keep in mind now, I am remote desktop to my PC on my office, controlling it through my Mac. And what we're going to do now is we're going to SSH into yet another machine and try to display all that information to my PC through, through the Mac. So,
I kind of lost. So you
yes,
on your remote desktop, you use Cygwin, and now you're using external again.
that's right. I could do it from my Mac, but I'm just the reason I did that is so I can show you how it gets started up on a PC,
So
on Windows
you
machine.
can start external on PC.
Yes, I just did. That's a PC right there.
It is a package of the Cygwin.
Yes.
Okay.
Okay.
Yeah.
It's part, and the question was, where is that? You have to actually install all of Cygwin in order to get that. Okay. So there we are. We're on the PC now, starting looking at that, looking at that piece. Oh, I lost my train of thought there. So let's actually SSH into Armstrong with my username rvrpci at Armstrong, or you can use Collins or Aldrin. Those are two other machines. So if things are bogged down on Collins or on Armstrong, you can use Aldrin and Collins, named after astronauts. So, all right. And now you can actually run and control control machines and programs that are running on Armstrong. So this is a situation where if you don't have, for instance, a license to run something on your local machine, you can log into a machine that has that license and still utilize that license. Okay. So for instance, if you want to use Envy, which is on the market, I think like a $4,000 or $5,000 piece of software, you may not necessarily be able to load it up on your machine, but you can log into a machine that you have access to and run that. And that's what we'll do right now. So I will say Envy Classic or MATLAB or what have you. Okay. And what you'll see is that this will actually be displayed, and I can control that like any other Windows package. All right. So everybody see that? So that's one of the powers of being able to use X Windows, because you have the ability to actually control something that's not local to your machine. All right. Now, one of the things that we'll talk about later is another environment called VNC. One of the issues with X Windows in general is that it's a very network-intensive process. In other words, it talks a lot from your laptop to the server, which is fine if you're in a very high bandwidth environment like RIT. But once you start trying to do this from home, for instance, through a through an asymmetric network, meaning that, which is the case for most home networks, it's asymmetric. In other words, your download speeds are not the same as your upload speeds. Okay, it can really, doing X through this can be extremely slow because of the fact that it's trying to, whenever you move a mouse, it's talking to the machine on the other side and say, oh, you moved the mouse, I have to redraw that. And then there's going to be this chatter throughout that network. If that network is slow, it can take you up to half an hour, maybe even 45 minutes for Envy to start up. Okay, and there is a way around that, which we'll talk about later. But just so you understand that the X Windows has its limitations in that it's a very chatty protocol. All right, so all right, so hopefully everybody sees this. Let me just. I had a couple more things on Unix that I wanted to go over, but then we'll jump straight to some image-related things. So what did I have here? Let me go back. So you can actually, well, we're here now. Let's close this up. You can start processes, putting it in the background. So that creates another Xterm window locally. Right. So this ampersand here says send it to the background. If I didn't do that, and I just said Xterm here, that process is still running. So I can't really do anything on this machine, on this window here, because there's a process that's blocking it. So the ampersand there allows you to send a program to the background, have it run, okay, and then you can access that. Very useful if you have very long-running programs that you want to run for a long time and still be able to use a terminal. All right. Let me see if I go over a couple of important key commands. I'll just jump through this. Yeah, a couple of keyboard control characters that are important. Okay. Escape key, you all have that. There was a time when I was started with computers that escape keys didn't exist. So that's the equivalent for escape keys. There's all machines have a, well, actually no, the Mac I think removed the escape key, the recent one. Control C stops the current running process. Right. So this is something that you need to remember, is that Control C will stop a process. Control Z will stop it, but you can restart it. Right. It's basically, it suspends a process. Right. So those are the two main control characters that will stop a Unix process, and one will suspend it, which means that you can still run it or restart it or send it to the background. Okay. A couple other ones, Control U erases a complete line being typed. Control S stops output to a screen, and Control Q, and then Control D is end of file. Right. So we talked about that yesterday. All right, let's skip through what I have here. This is a common problem. Hopefully, if you guys run into this issue, sometimes backspace and the delete character are messed up. Just remember, you don't need to do this. Just remember that there's a way of actually specifying which one will actually delete a character. But this is something that I haven't seen people have to face in the past few years. It may be because I haven't taught this class in a while, or people haven't used the Unix system. But there's always some issues with using the backspace and the delete key on a keyboard. And there are ways of actually working with that, so I won't dwell on that too much. Some Unix commands to try, even if you don't have a X going on, you can actually do the following things. You can type "Who am I?" So this prints just to show Control Z. That just basically stopped that terminal. Let's actually look at some of these commands. Who am I? Tells you your username. Host name tells you where you are, or the machine that you're running on. Particularly useful if you try to delete directories. Sometimes you really want to know where you are and what machine you're on before you start doing deleting stuff. Yes?
Yeah, you launched before that some program to launch or something. Why that was useful? Now you're working in Xterm. So why did you use it?
Because it was in front of me. I can go back to the PC if you want.
Oh, is it now on PC? Because I said that now you're talking about PC.
No, the X Windows is universal. It's Xterm and X Windows is universal. It doesn't matter whether you're on a PC or a Mac. It's just that you use different methods to actually access the Unix workstation. Okay. So Xterm is, think of it as a sort of a universal terminal that you can run both on a PC and on a Mac to access a Unix workstation.
And I can access remotely the server?
Yes,
Register.
yes, yep.
And I can display.
Yes, you can. If you've got Xsigwin, you can display things back. Just keep in mind, however, that if you're on a network that's fairly slow, it may take a while for the stuff to show. Okay, just be aware of that. There are ways around that, and we'll discuss that later. So this one tells me that I'm on this machine on my laptop. If I SSH into Armstrong, for instance. Okay, it's gonna, and this is one of the common things that people run into, is that they forget that their username is different than the other one. So what I actually had to do here is say rvrpci. All right. Okay. Other commands. So if I say hostname, it tells me what machine I'm on. Finger tells you who's logged into that machine and who you can yell at for because they're running some jobs that are pretty that take a while. Date is a common one. That's fairly straightforward. So, and I just want to show that this is basically a tree structure. Unix is the directories. Even though they're presented to you as folders within folders within folders, the concept behind a Unix directory is a tree structure. So you're at the very top is what's known as the root directory, and then you will have your own home directory, where you can actually create other stuff underneath that. Right. So I mentioned this yesterday. Absolute paths. All absolute paths begin with a slash. All relative paths are anything that doesn't start with a slash. Right? And this is something that people sometimes get confused with. They put a slash in front of a directory name, expecting it to be the directory in their home directory, and it's not. Okay. So if something says command not found or permission denied, make sure that you are in the proper directory where you want to create a file or CD into. We talked about ls. All right, ls is just listing your directories, home directories. It can be specified either absolutely, as in CIS staff, or tilde. So if you know somebody's username, you can just say tilde that username, and we'll put you directly to their home directory. So let's go over this really quickly, just to review some of the things I talked about last time. So look is a command that allows you to look into a dictionary within Unix. Right. So look, REL, gives you all the entries in the directory, but you saw that there's a lot of them went through. What you can do is pipe this through a command called more, which will allow you to essentially be able to look at that information, okay, or page through it using the space bar and going back using the it didn't work here, but usually the B button will allow you to do that. Right. Now, this is a concept called piping, where you take one command and pipe it through another command. All right. If I said WC, which is word count, it will tell me that there are 427 words that were shown, 427 lines, and 4,277 characters for that command. So if I just said look rel, that gives me the statistics of that information. So you're saying, well, what is this useful for? Well, it's kind of useful because what you can do is chain a whole bunch of commands. So we showed you BC minus L last time, where it's a calculator. So you can see 2 plus 2. Okay. And you can also have a little bit of a for loop here, where I'm going to cut and paste this command here. Let's see if it works. Sometimes this doesn't. Middle button. And it shows me, just went through that for loop in the calculator. Right? So you say, well, what good is that? Well, Control D here. Well, it's actually useful. Let's skip that one. Because what you can start doing is you can do output file redirection. Now suppose I wanted to save this output. I could actually say echo and then type that to BC minus L. What is it doing? What this command is doing is that it's sort of simulating you typing that command directly to BC. So if I hit return now, it output all that information to the screen. But you say, well, that's useless. I want it to go to a file. Well, you can do that too. You can say now my data.txt, and now if I say more my data.txt, you'll see that you have that information there. All right? It's all in the file, so you can process it. You can try to plot it in something like GNU plot. There's a problem here, however. What's the problem with this file? Okay, just follow along. Yes, I understand. just follow along. Just watch and try to understand. If I try to import this into Excel, what's the problem? No.
You know where the tabs are?
There's only one column.
Yeah.
It's only one column. So how do I take care of that? Well, there's a command in there's yet another command in Unix called paste, and the syntax is the following. It allows you to just do that really quickly. All right. If you had to do that in any other way, you'd be going through each individual line and basically inserting a character for that. In this case, the paste command basically says, give me everything, and I'm going to put it in 2 columns. And now I can save that into a new file saying new data.txt. Right, so if we look at that, and now I can actually say something like GNU plot, which is one of the plotting packages that a lot of people in Unix like to use, and say plot using 1, 2. And using plot. Oh, sorry. Plot. Oh, never mind. I was being dumb. Plot my data. I call it my new data or new data. Using. There we go. So, you know, what I see people doing sometimes is like, oh, I've got this file. I'm going to go and export it to into my local machine and you know, plot it up in Excel. And that's fine. I mean, I get it if you want to do a final graph, for instance. But if you just want to look at something, there's no need to transfer that data. You can just do it directly in the in Unix. So again, there's a lot of commands there that allow you to do quick processing of the data. So what we'll do now is we'll move on to actual image information. All right. And let me just go through the slides. It's kind of sort of what I had before. Yep. Okay. These are for GNU plot. All right. So here's my lecture here. There's data and display. And this is a format that a lot of people are not aware of, and I will school you on it. And this is what's known as NetPBM format. NetPBM was originally designed as what's known as an interchange format. So many of you have probably been exposed to JPEGs, PNG, TIFF, BMP, raster formats. Well, if you had to actually create converters through each and one of those different formats, you would have to essentially create one to all of them. One to all of them, and one to all of them. What NetPBM was designed to do is to create what is known as an interchange format. So instead of you having to create all these different converters, you convert it into an interchange format, NetPBM. So basically, you only have to create that converter, and then once it's in NetPBM, you can convert it back out into the other formats. All right. And if you need to learn any specific image format, NetPBM is the one, because it's very, very straightforward, very, very simple, and actually we can actually create that in we can create an image in an editor, which is something you can't do with JPEG or any of those TIFF files. Okay. So NetPBM is divided into actually two major categories, each category having these three. So NetPBM will accept what is known as a bi-level image data type, which is black and white, and then you have a monochrome, which is grayscale, okay, and then also RGB, which is everybody's familiar with. There is, however, this division between the two called ASCII, which I term being for human consumption, okay, and then a raw format meant for computer consumption. In other words, you're not supposed to actually be able to look at a raw file and make sense of it, whereas you can probably look at a NetPBM or a NetPBM ASCII file and kind of say, okay, I know what this image should look like. Right? And those are two representations. And this also helps people sort of get over that whole binary concept of data in computers. So let's talk about PBM. So this is what known as a portable bitmap. It's for bi-level image data, which is meant for just black and white. So the only two levels that you can have for a given picture element, for a given pixel, is 0 or 1. Okay. In this case, this was actually based on fax machines. So you used zeros to represent white and 1 to represent black, okay, because it is a printing, it was based on a printing format. So this is a small image. So portable bitmap has the following signature. In other words, there's a special set of characters that will give you information regarding the file. The magic number that they use here is P1, right? And this is for an ASCII map. Okay. So one of the nice things about NetPBM or PBM format is you can actually put comments here. So I put a comment here indicated by the pound sign. And it said, this is a 16 column by 3 row PBM ASCII image created using a text editor. Okay. So those 3 lines there are comments. The next 2 lines indicate the number of samples and number of lines of this image. Okay. So capital P1, okay, comments, and then 16 by 3. So I'm going to now escape out of here and actually go ahead and copy this. All right. And because this is a demo, it's probably not going to work. But let's go ahead and go into Unix land and images. See the images. And I'm going to create this file. So I can create I can go into, let me see if this is as big as yeah, it's as big as it can get. I'm going to use VI, but I'm going to use Nano for now so you guys can see this. Let's call it my image.pbm. And I'm actually just going to paste it in there. And I'm going to get out of this, Control X, let's say yes, right there. All right, there it is. We can say more my image.pbm. Looks reasonable. All right, let's actually look at it in one of the viewers. Let's start up GIMP. I could do a display on this, but we'll talk about some of the things that display does that is kind of weird. I can say File, Open, and oops, and load that up. Load that baby up. And sometimes people go, well, I can't see the image. Where the heck is that image? Right? Well, think about it. It's a 16 by 3 image, so you shouldn't be able to see it easily. But if we actually zoom in on it, there it is. Okay. So if we look at the patterns here, we can actually we can see that it mimics what we have here: 0, 0, 1, 0, 1, 0, 1, 0, 0, 0. So this pattern actually matches that. Now, one thing you'll notice is that we only have 2 lines of zeros here, 2 lines of ones and zeros here. But because you give the dimensions, it automatically formatted that file properly. You could have put these ones and zeros into one long line, or one value per line. It won't matter. Okay. It knows that it knows because of these two metadata information, data about the data, 16 samples by 3 lines, and that's where I get this this information right here. All right. So can't do that with can't create a JPEG file using an editor. That's one of the things that I tell people, like, if there's one format that you should know, it should be this one. Okay. Any questions with that? If you want to look at the values in GIMP, this is actually something that I always have to look for because they, programmers are not necessarily designers, and I could never find this, and I had to actually spend another 20 minutes before class to find out where the more critical tool is, which is to look at the values with this. So it's in here, this thing, and it should be add tab, and it's called pointer. Where's pointer? Yep, there it is. Okay. So now this gives you pixel values and the values associated with each one. So this is pixel 00, 1, 0, 2, 0, 3, 0, etc. So you can actually interrogate each of these in GIMP and get the appropriate values. Okay. All right. Any questions about that? So if you've got something that is binary or bi-level, you can use this format. So let's now go back to the other sets of formats that I want.
Display it.
What's that?
Can we display it with the display?
What about the display command?
Yeah, can we display?
You can. Here's the problem with the display command. The display command, unfortunately, does some interpolation. So if we actually say display my image.pbm, okay, and it's up there. Oh, wait a minute. I think this one it did properly, but it does this. It does some interpolation, so it's not as true to the values. This will become less, not as, will become even worse when we actually talk about the PGM format. Okay, but yes, you can use the display, but it does a lot of interpolation when you zoom it up. So you can see it's only a 16 by 3, but as you can see, it's trying to apply some sort of anti-aliasing, which is not really what you want it to do. So there's a way of, I think there's a way of turning it off. I just don't know. So
Is it good to all images?
The interpolation for display, most likely yes, but that's what I always tell people. If you're using displays, never use the display as a source of data. Okay, the display, when you say display, it's only meant to be seen, not necessarily processed. All right, so yes, you just have to be careful about that. This is a prime example where the display is doing something that you really didn't want it to do. And what sometimes people try to do is they'll say, oh, I'm going to save the display and then use that data. Well, that's wrong, because the display will have applied some sort of correction to make it optimized for viewing rather than for actual manipulation or actual mathematical manipulation. So, no, that's a good question with that. I didn't really I tested this with the PGM and it looked bad format. So. Now I lost my lecture notes. All right. So that's where we are. And I do have to cut out at 3:20 because I have a telecon. I didn't tell people that. I told some people that, but. All right. And I said this can also be written as 16 by 3. Okay, it does the same thing. But there's also this binary format, okay? If you look at this, it's P4, okay? And this is a raw image. And if I actually take this image and type it in, same way I did, I won't do it, but, well, if you want me to do it, I'll do it. But if you use the same set of information, you'll come up with the same image. Okay, and it's in binary. This is in binary form. And first look at that. You're saying *4 greater than HR/ what the what. Okay, but there is a reason for why you get the pattern that you see right there. Why? We wanted. Okay, let's hold that off, and then I'll show you why you get that pattern. And when I explain it to you, you'll say, oh yeah, okay, that makes sense. Not right now, and that's why I said raw images are not meant for human consumption. You're not supposed to be able to look at that and sort of say, oh, I know what this image looks like. Talk about PGM. This is one that you'll probably be using more than the other one, than PBM. But the PBM actually has some merit in then being able to show you what's actually going on with regard to that pattern that we just saw in the raw format. So keep in mind that the PGM is actually a display, is meant for display, so that low values are dark versus low values in PBM is white, okay, because the first one that we talked about is meant for printing and depositing ink, whereas PGM is meant more for to specify a display, and the gray levels are proportional to some brightness, okay. And as I mentioned, that's kind of opposite of the PBM format. So here's an example that we want to do, and we can do the same thing that we did here. Do the same thing, cut this. Actually, I meant to correct this and I never did. Let's go to...
Manipulations are they capable of doing this that we have?
A lot. I mean, one of the things that, if you look at NetPBM, there's a lot of things that you can do with NetPBM. If you Google NetPBM, there's a lot of things that you can do on this kind of format. You can convolve, you can mosaic, you can resize, you can flip, you can, and convert it to other formats. You can convert it to JPEG, PNG, what have you. Okay. I'm not going to go through all of those because those are things that you probably cover in class, but you just need to know that you can do it with NetPBM and also with ImageMagick. Okay. ImageMagick is another set of tools that that we have here. Display is actually part of ImageMagick. Right. So there's a whole host of command lines associated with ImageMagick that allow you to do a lot of things that most of them who don't know about that, first thing they'll do is they'll write some MATLAB code or some C code to do those processes, or go into Photoshop or GIMP to do that. But you can actually do it in either NetPBM, PBM, and ImageMagick. Okay. So, and I'm not going to go through all those. Those are things that you can easily find out for yourself. You just need to be aware that you can do that with those commands. Okay. So let's look at this one. So I'm going to cut this out, and you can almost sort of guess what's going to happen with this one also. Image.pgm, portable gray map, using a VI this time. Oops, wrong one. I didn't cut that out properly. Edit, copy. And as you can see, I'm copying between a PC and the Unix system. So, oops. Try that again. And let's use GIMP, because here I'll show you what happens with display. My image.pgm. Oops. It's there, but it does so much interpolation that you can't see it. But if we look at it through GIMP, okay. Okay. So there you go. There's your image. And we can interrogate this also as before. Where's Mr. Pointer? Pointer. Where's Pointer? 42, 52, 62, 72, 82, 92. So there's consistency with what we typed in and what we're seeing in the image. So if we want, we can do a little bit of equalization here. Tools. That's why that's why I never use Photoshop, because I always get lost in all the different locations. I'm trying to look for histogram equalization here. Anybody sees it, let me know. Nope, I don't see it. I don't see it. Anyway, think it's an image?
Yes.
Transform? No.
Probably.
No. No.
Color looked like it had all
Which one?
the, color looked like it had all
Might be in there. Threshold. So blah blah blah. Auto. Oh, it's probably under auto. Equalize. There you go. Yeah. Stupid. I hate these things. That's why I like command lines. Like, let me type it in. So looks pretty straightforward. So back to the notes. So that's fairly obvious once you've seen it. I have the wrong values there. And then there's another one called Portable Pixel Map, which is PPM, right? And it's red, green, and blue bands. So, and then this also introduces the concept of interleaving for multi-band images. How do you actually lay out the different bands? Okay, the PPM format is what is known as band interleaved by pixel, BIP, which means that you get red pixel, green pixel, blue pixel, red, green pixel, red pixel, green pixel, blue pixel. Okay, the other concept that you have is band interleaved by line, which would say red line, okay, green line, blue line, and then the last one is BSQ, which stands for band sequential. Okay, now some of you may ask, well, why do you have those three different formats? And it all reflects back to what kind of scanner you might be using. Okay, if you have a scanner that has only one detector, but multiple bands, it's much more efficient for it to generate band interleaved by pixel as you scan that particular point across an image, for a document, for instance. Okay, let's think about it in terms of scanning a document. If you only have one detector, you would use the band interleaved by pixel to save red, green, and blue pixel, move a little bit, red, green, and blue pixel, move again, and so on. For the band interleaved by line, you can think of your lines of your flatbed scanner. Okay, your flatbed scanner has a red line of detectors, green line of detectors, blue line of detectors. As you move it across, it'll be reading red line, green line, blue line, red line, green line, blue line, etc., etc. And the last form is band sequential, BSQ. You can think of as having a framing set detectors, a monochrome framing sensor, and then you would have filter wheels in front of it. So what you would do in that situation is you would say, let's put the red filter on, take all the pixels. Once you're done with that, flip it to the green filter wheel, take all the pixels, and then go to the blue and do the same thing. So that's why you have those three types of formats with regard to multiband data. And it's important to sort of know how your data was generated, because you can get really wacky wacky artifacts if you try to display something when it's actually in a different type of interleaving format. So just be aware. From experience, a lot of engineers who create scanners or cameras don't really document their stuff very well. And what they would tend to do is just dump the data and then give it to you with very little information. And you get into this whole process of doing what's known as mystery image processing, because they won't give you critical information like how many lines per how many lines and how many samples. And because they're not, they just want to generate the data. They don't really care about, putting it in a JPEG. I mean, that's one of the last things they want to do. They just want to get the data as raw as possible, and then it's somebody else's problem to analyze that information. Particularly, it happens a lot in scientific instruments. So that's sort of one of the reasons why I try to emphasize the fact that you have these possible interleaving formats. So, okay. And I won't go into this too much, but it's red, green, blue, red, green, blue, red, green, blue. So what we're seeing here is essentially the red pixel, 225500, that's red, green, and blue, 02550, green, etc. Okay, most of you are familiar with this already. So, all right, let's see what
So
else.
is that giving it the max value
What's that?
after you have the 0 3 and it's set to
Oh yes, I'm sorry. I meant that's something I missed also in the portable gray map also. Yes,
oh, go with the max value.
max value. Yes, max value. What you have to do is you sort of have to tell the portable gray map what the max value is that you want to represent for this. I'm sorry, I totally. I do, that you want to use. Sometimes this will be used for actually scaling when the display. Okay, so if you only have like 16 values, for instance, and you put 16 there, when you display it, it'll try to scale it so that it'll look better. But 255, and again, 255 is a magic number because it's the maximum integer value that you can put into a byte of data. That's why you see a lot of your images are just basically 1 byte of data. From a perspective of visual, that's sufficient. But when you start dealing with instruments that are more sensitive than the human visual system, you have to have more bits there, and that can cause another set of problems that we'll run into when we start talking about binary data. Right? But thanks for that catch there. Yes, the maximum value for each of those things.
You had it.
Yeah, I had it written there, but I didn't verbalize it. So pretty. This format is one of those things that everybody should know. Now back to this. What we didn't show you, however, is that. So we did this for. Come on. Why can't I cut that out? I'll just have to do it by hand then. So we did myimage.pgm. So let's do myimage.raw.pgm, and that's a P5, 3 by 2, 255. And let's actually type this in. Star 4 greater than HR slash. Okay. And let's look at that in GIMP. I save it out. Oh no, myimage.raw.pgm. It's a demo. It's not going to work. They put it in here. Right. Let me try that again. So just to show you, I'm running GIMP right now. I can actually send it to the background. I hit Control Z and type BG. and it's in the background. So now I can actually use the terminal now and go back and create that. So I have that my image raw.pgm P532255. It's under images. How come it's not picking it up? Let's try that again. VRPCI images. Oh, there it is. It probably just didn't refresh. Okay. And open. Oh, I didn't. Did I put 255 there? Let's check again. No, it's there. So it's the same. Right. If we actually go through that, this is actually a pointer. If we actually check the values on that, pointer, right? It's 42, 52, 62, 72, 82, 92. It's exactly the same as the other one. Right? So what you have here is two images that generate the same image, but in different formats. So I think this is a good place to break and kind of say, okay, why is that? And let you guys think about that why that is the case. And there is definitely a reason for that. So, okay, any other questions? So, one of the things that we'll be doing past this is actually using, trying to extract information from image information, and then using some text processing tools to find out, for instance, the dimensions and how you manipulate that in the Unix environment, okay? And how you would pass that off to other scripts to do more processing. Now, keep in mind that these are the things that you would probably have to do in situations where you're dealing with hundreds or thousands of images that you need to process. It's not something you want to do through a graphical user interface. You want to have some sort of scripting environment in order to be able to do that. So we'll discuss what that duality of data when next week. So if you guys find out what it is, hopefully you will. Anybody have any idea what's going on there?
There's 6 characters for 48, so each one's 8, so I guess it's 200 bytes.
That's right. That's right.
It's like the ASCII equivalent.
Exactly. It's the ASCII equivalent. And if you look at the bitmap, what do you think? What do you think is happening there? So it's the binary of 42. Okay. Binary of 42, 52, 62, 72, 82, 92. So, yeah. Okay. Sorry to cut you guys short, but they gave. All right. So we'll see you guys on Tuesday.